Swayam Prabha. Digital India. Educated India.
Welcome to the course Geology and Soil Mechanics. So, in the last lecture, as you have seen, we took one problem, and that problem was on this topic, that an undisturbed sample of saturated clay has a volume of 16.5 cc and weighs 35.1 gram. On oven drying, the weight of the sample reduces to 29.5 gram. Determine the void ratio, moisture content, dry density, and the specific gravity of solids. So, this problem was taken in the last lecture, where we solved the problem by a method 1. So, as we promised in the last lecture that we will be solving the same problem by some other method using the phase diagram, whatever you have seen in the previous lectures, and that is more fundamental, coming from the basic. So, your understanding will be more better if you consider the phase diagram. So, let us see if we solve the problem by using your method 2. So, basically let us draw the phase diagram first for this kind of saturated soil. So, as you know, so this is a completely or fully saturated soil. So, your phase diagram, 3-phase diagram will be boiling down to the 2-phase diagram, that means water and soil solids. So, you have water and solid, and on this side you have the weight scale. So, this is your weight of water and this is your weight of solid, and on this side you have the volume scale, volume of water and volume of solid, and the total volume is, say, V, which is equal to 16.5 cc. So, that is given in the problem, and the total weight, if you look at the problem, the total weight is also given, that is 35.1 gram. Okay. So, here weight of the wet sample W is nothing but your 35.1 gram, right. So, this is the total weight of the sample. Okay. Then weight of the dry sample, which is nothing but WD, is your 29.5 gram, as it is given in the problem itself. If you see that on oven drying, the weight of the sample reduces to 29.5 gram. That means whatever water was there in the sample, so that has been evaporated and that has been removed from the sample, and ultimately you have got the dry unit weight, dry weight of the sample WD is equal to 29.5 gram. So, weight of water which was present in the sample, which was nothing but WW, is 5.6 gram. So, let us complete the phase diagram then. So, now you have got WW is 5.6 gram, and Ws is 29.5 gram. Okay. Now, what will be the volume of water then which was present in the sample? So, volume of water is nothing but your volume of voids. So, we can write, because that is fully saturated, the all void spaces were occupied by the water. So, Vw is equal to Vv, which is nothing but 5.6 cc, because this is your weight, and if we consider the unit weight of water is 1 gram per cc, then you will be getting Vw is nothing but equal to Vv, that is volume of voids, is equal to 5.6 cc. So, I can write this is 5.6 cc. Then the total volume V. So, you can make a note here that your gamma W is 1 gram per cc, and that is why you are, if that is the assumption, we are not assumption, basically it depends on the temperature, but we are considering gamma W is 1 gram per cc for my problem. So, ultimately you have got the volume of water like this. So, total volume V is given as 16.5 cc, as you can see on the left hand side of the phase diagram. Okay. So, your volume of solids therefore will be coming as Vs is equal to V minus Vv, which is nothing but 10.9 cc. So, now you complete this part 10.9 cc. Okay. So, you have got all the things, volume of water, which is nothing but the volume of voids, you have got as 5.6 cc, volume of solids you have got 10.9 cc, and weight of water is 5.6 gram, whereas weight of solids is your 29.5 gram. Okay. So, after getting that, then what are the things you need to find out? As before, void ratio, moisture content, and what else? Dry density and the specific gravity. So, these 4 things you need to obtain. So, let us see how we can obtain those things from these parameters. So, your void ratio E is given by, very simple, Vv by Vs. So, Vv by Vs. Now, you know both the terms. So, what is your Vv? Vv is nothing but 5.6 cc. What is your Vs? Vs is nothing but 10.9 cc. So, if you put the value, you will be getting void ratio E is equal to 0.51. So, you can match this value with your previously obtained value by using method 1. Okay. So, therefore, the moisture content is given by small w is equal to WW by WS, very simple. So, basically in the method 2 you need not to remember the relation, whatever relation we have seen in the last lecture, that you have established some relation of E or moisture content or something like that, but you need not to remember all those things for method 2, because you are coming from the basic, coming from the phase diagram. So, everything, or if you need to know only the simple definitions or the fundamental definitions. So, if you put now what is your WW, that is 5.6 gram, and what is your WS, 29.5 grams. So, if you put the value, you will be getting 0.189, which is nothing but 18.9%. Okay. Now find out dry density. Gamma D is equal to Ws by V, very simple. So Ws is the weight of solid by the total volume. So that is nothing but your gamma D, and if you put the values 29.5 by 16.5, it will be coming as 1.79 gram per cc. Now which one is left? The specific gravity. So let us find out the specific gravity. So your unit weight of solids gamma S can be obtained by this definition, very simple, right? Ws by Vs. So if you put the values, you will be getting this as 2.7 gram per cc. So therefore specific gravity Gs, what is Gs? That is gamma S by gamma W. So gamma S is your 2.7 and gamma W we are considering 1. So you will be getting 2.7 is your specific gravity. So this is the whole problem. Whatever problem we had taken, the problem 1. So that problem has been solved by two different methods. In one method, in the first method, basically you have seen you need to establish or need to remember some relation among the parameters, whereas the method 2 describes the problem starting from the basics, which is nothing but your phase diagram. Okay. So we will take the next problem. So we will take the next problem, that is problem 2. The problem 2 says the bulk density and dry density of a partially saturated soil are 1.95 gram per cc and 1.8 gram per cc respectively. Okay, that is bulk density and dry density. Okay. The specific gravity of solids is 2.68. Determine the void ratio, moisture content and degree of saturation. Okay. So basically when we are talking about the bulk density and dry density, and if we consider the bulk unit weight and dry unit weight, they are related like in terms of G, as I told you, acceleration due to gravity. Anyway, so basically this problem says that is bulk unit weight is 1.9 gram per cc and dry unit weight is 1.8 gram per cc if you consider in the unit weighted term. So anyway, so let's solve this problem. So problem 2, we have gamma D, that is dry unit weight is nothing but bulk unit weight by 1 plus moisture content W, right. So this relation you can establish, so it is not the new relation or it is not the empirical thing. Basically from the basic definition of gamma D and gamma B as well as the moisture content, you can establish this relation, though I am not talking about those relations specifically, but any textbook or whatever textbook I have suggested, from there you will be getting this relation and you can establish this relation. Okay. So here gamma D is 1.8 gram per cc and gamma B is your 1.95 gram per cc. These things are given in the problem. So if you look at the problem, these two parameters or these two unit weight or the density value are given. Okay. So if you put these values in this expression, then basically from this expression you will be getting 1.8 is equal to 1.95 by 1 plus W, that is the moisture content. So, from this you will be getting W is equal to which is nothing but 8.33%. Okay. Now, again we have gamma D is equal to again this relation can be established by following the simple definition of these parameters. So, gamma D is equal to Gs, that is the specific gravity, multiplied by gamma W by 1 plus E. So, in this expression if you put the values 1.8 is equal to 2.68, that is given in the problem, and gamma W we are considering 1 plus E. So, from this expression you will be getting E is equal to 0.49. So, the void ratio of the sample is 0.49. So, we have got two things, void ratio as well as moisture content we have determined. Now, degree of saturation, that is S. So, degree of saturation is basically related with this relation. Again you can establish that moisture content multiplied by the specific gravity is equal to degree of saturation multiplied by E. So, I am not showing the derivation as I told you before, it can be derivable and you can derive it by yourself if you know the definition of all those things. So, your degree of saturation is nothing but moisture content multiplied by the specific gravity by E. If you put all the values whatever you have obtained just now, you will be getting 45.6%. So, that means this is partially saturated soil and the degree of saturation is 45.6%. So, I mean these two problems, the problem 1 as well as the problem 2 will give you some background or give you some idea how to solve or how to find out different parameters which are really required to define the soil property. Okay. Now, we will be taking another problem which are based on the index properties. So, let us see those problems, another two problems we will be considering. Okay. So, next problem we will take on this on the index properties of soil, that is the Atterberg limits of given soil are the liquid limit is 60%, plastic limit is 45% and the sinkage limit is 25%. So, these limits are known to you, already we have covered this thing and you know the basic meaning of these limits, liquid limit, plastic limit and sinkage limit. The specific gravity of soil solids is 2.67. A sample of this soil at liquid limit, that is LL, now we will be defining liquid limit as LL, plastic limit as PL and sinkage limit as SL. So, a sample of this soil at liquid limit has a volume of 20 cc. So, in the liquid limit the sample is having the volume of 20 cc. What will be its final volume if the sample is brought to its sinkage limit? So, you know the different limits, that is liquid limit, plastic limit and sinkage limit. Now, you know the volume of the sample at liquid limit and now you are basically taking the sample to its sinkage limit and you want to find out what is the final volume. Okay. So, let us start this problem. So, basically we will be solving this problem by using our basic definition, that is the phase diagram. So, the problem 3, the 3 phase diagrams of the sample at its liquid limit and sinkage limit are shown below. Okay, let us draw that. So, this is your phase diagram at liquid limit. We are considering unit volume of soil solid, so 1, and the volume of water at liquid limit, this is at liquid limit. So, the volume of water at liquid limit, say EL. So, these are the things we need to find out. So, we are considering or we are assuming the soil solid volume is 1 unit volume we are considering. So, your total volume will be 1 plus EL, there is no issue for that. Similarly, if I try to draw the phase diagram in sinkage limit, this is your solid, this is your water. So, your volume of soil solid will not change at all, right? It will be remaining same, because you are not, you are basically you are dealing with the same soil sample starting from the liquid limit, you are coming to the sinkage limit. Okay? So, but nowhere you are changing the solid particles. So, the volume of solid particles will be remaining same, and that is say unity. Okay? So, and we are considering the volume of water, okay, is ES at sinkage limit. So, total volume as sinkage limit will be 1 plus ES, very simple, right. So, what is the reduction in the volume of water from your liquid limit to sinkage limit? That is nothing but EL minus ES. Okay. So, if you start from the phase diagram, it will be very convenient to understand. Okay. So, now let us start this thing. Let EL and ES be the void ratio of the soil at liquid limit and sinkage limit respectively. And let the volume of solids be 1 cc. So, these are the things we are assuming. So, we are assuming the volume of solid is 1 cc and the void ratio at liquid limit is EL and void ratio at liquid sinkage limit is ES. Now, you think about that. So, what is the definition of EL then? VV by VS at liquid limit. Okay. So, what is the volume of solid at liquid limit? 1, that is already assumed, that is unity. And then what should be the volume of voids? Then VV should be equal to EL. So, this is the volume of voids. Okay. So, that is why I have written EL. Fine. Similarly, in case of sinkage limit, if you see this is your unity, the volume of solid is say unity. So, your VV by VS, that is nothing but your VV by VS at sinkage limit is equal to ES. So, ES is nothing but equal to volume of voids at sinkage limit. very simple. So, that is why we have considered unity, so that we will be getting the direct interpretation of your volume of voids. Okay. So, we have we know that as we discussed just now. So, your VV, that is the volume of voids for any sample, is nothing but E into Vs, that is the void ratio multiplied by the volume of solid. Okay. So, at liquid limit, your VV is nothing but EL multiplied by 1, whatever we just talked about. So, that we are writing here. So, ELCC. Okay. This is the volume of void at liquid limit, and that is coming to EL. Okay. Now, volume of water present is therefore ELCC, because the void is completely occupied by the water. So, whatever volume of void is present in the soil sample at liquid limit, so that is nothing but the volume of water. So, I will keep the phase diagram for my future reference. Therefore, weight of this water, whatever water is present in the voids at liquid limit, is nothing but EL multiplied by 1. We are considering the unit weight of water is 1 gram per cc, is equal to EL gram. Okay. Now, weight of solids therefore is equal to Vs, that is the volume of solid multiplied by Gs into gamma W. So, weight of solid, say Ws. Agreed? Vs, that is the volume multiplied by Gs into gamma W, that is nothing but your gamma S, which will eventually give me the weight of solid. So, if you put the values, what is the volume of solid? We have considered unity. So, 1 multiplied by 2.67 multiplied by 1. So, 2.67 is the specific gravity as given in the problem. So, it is coming to 2.67 gram. So, your water content W is given by WW by WS, which is nothing but EL by 2.67. Okay. But at liquid limit, what was the water content? So, if you go back to the problem, it says this is 60%, that is nothing but 0.6. Okay. So, at liquid limit, this is the expression for water content, and at liquid limit the water content is given in the problem as 0.6. So, we can equate these to EL. Therefore, EL by 2.67 is equal to 0.6, from where I will get EL is equal to 1.602. That means the void ratio at liquid limit in the sample is 1.602. Similarly, we can find out the void ratio at sinkage limit. Similarly, at SL at sinkage limit, ES is equal to 0.25, that is 25% is given in the problem, that is the water content, that is the sinkage limit basically. That means the water content at sinkage limit is equal to 25%, and from this we can find out the void ratio at sinkage limit, which comes to 0.668. Therefore, change in volume per unit of original volume is nothing but delta V by V, which is nothing but EL minus ES by 1 plus EL. So, what is your delta V? That is the change in volume. So, what is the magnitude of, or what is the expression of change in volume? This much is your change in volume, because this was the phase diagram at liquid limit. Now, after drying cycle, you are getting the phase diagram like this at sinkage limit. So, this much is your change in volume, the reduction in volume, and that is due to the evaporation of water or removal of water. But whereas your volume of solids will be remaining same, there is no change in that. So, the total volume is 1 plus EL, earlier original volume of the sample at liquid limit 1 plus EL, that comes here, and EL minus ES is your volume of change, or the change in volume. So, from this we can write down delta V by V is equal to 1.602, that is EL minus ES. Just now we have obtained these two values, divided by 1 plus 1.602, this comes to 0.359. Therefore, your change in volume is 0.359 into V, and what is the volume is given at liquid limit? If you look back the problem, a sample of the soil at liquid limit has a volume of 20 cc. So, this V is your 20 cc, which comes to ultimately 7.18 cc. So, this is the change in volume. Hence, final volume at sinkage limit is equal to 20 minus 7.18, which comes to 12 point. So, this is the final answer. That means the final volume at sinkage limit. Okay. So, now if you look at this problem, basically this problem is started with the condition what was present in the soil sample at liquid limit, and from that liquid limit we come to sinkage limit after reduction or after removal of some water, and the volume earlier at liquid limit was 20 cc, and at sinkage limit it comes to 12.82 cc. Thank you.